Hello everyone, my name is Richard Schneeman and I want to talk to you about the scariest thing a Ruby programmer can face. Wait a second, you hear that? Everyone, run! Run! Oh no! Oh no! Ah, there are more of them! Whew, okay, wow. They followed me from RubyConf. I can't believe 2 conferences in a row. Who would have believed? Wow, what a coincidence. Okay, so if you have seen that talk, know that there is a lot of new content in this one and you will not be disappointed. And while dinosaurs are scary, there's something that's even scarier. It's syntax errors. Hey, don't laugh. Syntax errors are scary. Just look at this unexpected syntax error, okay? It's horrifying. Where's the problem? Here's some different code. Want to guess where Ruby thinks the problem is? Yeah, last line. Nope, wrong. This is frustrating. I am frustrated. What if we had something better? What if we could take this and turn it into... Oh, yeah, look at that, line 5 right there. It looks like it's missing a do. Okay, all right. Have you ever seen, like cooking show? They show you the final product. I want to show off dead end in action to get started. Here's a demo of how it finds syntax errors. Here's a real document, real syntax error, last line, of course. And then this symbol up here means that the entire document cannot parse. So we're going to transform it until it can. All right. All right, when a valid source code block is found, dead end safely removes it. After each step in the search, then dead end reevaluates the whole document to see if it's parsable yet. Parsing failed, so we need to keep looking. Still failing, expanding out, still failing. Are you the syntax error? Are you my syntax error? Still failing. Searching for that syntax error. Still failing. No, still can't parse the document. Maybe it's up here. Maybe? No. It doesn't look right. I don't think it's in there. Well, okay, the document is going to be checked. And, ooh, okay, wow. Okay, the parser reports that our minimal document is now parsable. That's great news. Once this happens, dead end has found a way to transform our document. It can stop searching and instead search the invalid code blocks it has. So this right here is the actual output of dead end on that file. The issue's on line number 36. There's a missing end statement. You can have it today for the low cost of free. Gem install dead end. By the time you see the slide, we're going to have 500,000 downloads, probably, at least. And I am talking with Ruby Core to get dead end integrated directly into Ruby. We are targeting integration for 2022, so not this year, but the next, for the release of Ruby 3.2, which also means that there's plenty of time for you to give it a shot and give it a spin and give me some feedback. All right, so you saw one example of dead end finding a syntax error. What else can it do? When you miss a keyword like if, do, or def, dead end finds the problem. What about an end keyword? Can it do that? Whew. Dead end finds the problem. When you miss a curly bracket, there's no way. Dead end finds the problem? What about a square bracket? Dead end finds the problem? Okay, What about a missing pipe character? Well, dead end finds the problem. Have a problem with a missing family member in a Korean thriller drama? Yeah. No, sorry. Dead end can't get, we're not going to touch that. All right, that was too dark, too deep. Let's go rewind. Let's try it again. Have a problem with a missing Marvel Universe character? Huh? Crocodile Loki? Come on, still funny. Still good. Still top. Crocodile Loki was 2021. This year is lasting forever. Oh, that was such a good show. Okay, so today we're going to dig into dead end. You can actually follow the algorithm yourself by running it with this record CLI flag. You'll see each step and along with the annotated source code. That's actually how I generated those original slides. That's coming from dead end. If you don't want to generate slides, just write a program to do it for you. Okay, so today we're going to be talking about syntax errors, lexing and parsing, a little bit of AI, touch on some dead end, get into some internals. But first, who's this guy? Let him up on the stage? I mean, let anybody on the stage these days. Well, I go by Schneems on the internet. If you forget how to pronounce my name, you can go to my blog, schneems.com, and click that little play button. I also created Code Triage, which is a platform for learning how to contribute to open source. To date, I've got over 60,000 developers. I think, like, I don't know, this is out of date. It's like 62,000, something like that. And you could sign up for Code Triage if you want to start contributing to open source. Speaking of open source contributions, I'm glad you brought that up. I'm actually working on a book. It is called How to Open Source. You can go to howtoopensource.dev, and you can buy the book as a pre-release. It's not quite ready yet, but it is a book all about contributing. It is for developers who don't know how to get started, who started and got stuck, developers who are looking for ways to sustain contributions. I've been running Code Triage for years, as well as doing a bunch of research and interviewing users, interviewing, developers all day long, developers. And so that is kind of like the synthesis of all of that work. So the book is How to Open Source. You can get to howtoopensource.dev. You can also sign up for codetriage.com, and I'm going to email members whenever the book is ready. When I'm not working on open source, I also kind of like to get paid. Currently, that's happening through Heroku and through Heroku Salesforce, where I am working on Salesforce functions. It's an easy way to work with the data inside of Salesforce with the language you love. If you love Java or JavaScript, you can use it right now. And we will be rolling out Ruby support later. People also tell me that I am an exceptional programmer, mostly because my programs, they generate a lot of exceptions. It's okay, I know what I am. Syntax errors, though, is the main exception we're going to be focusing on today. And let's start from the beginning. What is a syntax error? Why are they so hard to understand? Well, this code works wonderfully, comparing A and B all day. Just a while loop. When Ruby parses the code, it converts it into an abstract syntax tree. So right there, yeah, you can see it. So yeah, that code generates that tree. The tree was beautiful, and Ruby's parser looked upon it with great happiness and glorious purpose. While the code was good, a stranger came upon the land. And the stranger had a secret power. Behold, the Octothorpe. With one key, the stranger used their power to transform the code. A critical line had been commented out. Without that line, the tree was no longer whole. Huge sections of the code no longer reachable. The code no longer parses. Our parser is sad. I'm a little sad too. With that, the stranger left, and behind them stood a syntax error. So, in short, a syntax error is when Ruby's parser cannot build a valid parse tree. That explains what they are, but why are they difficult to understand? Well, when the parser tries to parse this code, it finds a syntax error, of course. Here, our developer forgot a bracket. As the parser is building the tree, it hit an error because we weren't expecting a comma. Ruby's parser has rules. It knows a method definition and what it looks like, and after it, it knows it should look for a return or a variable assignment or something. What did it find instead? Well, it found a number and a comma right there. Yeah, which violated its rules. It violated its expectations. Do not collect 200. No, yeah. Sad parser. So what's so bad about this example? Well, the error isn't caused by a comma. It's caused by a missing bracket. That's a pretty major difference. Essentially, the location of the parse error isn't always where the developer made the mistake. Let's look at a more complicated case. Here's code with a syntax error in it. The developer forgot a space after the def. Ruby thinks that the error is on the last line. Right there. Why? Well, when we started parsing, Ruby sees a module definition. A module is a keyword that requires an end, so Ruby starts looking for a matching end. On the next line, it sees this combination of characters. It doesn't know what it is, but it doesn't have a problem with it. Maybe it's a method call or something. I don't know. Then it sees this end and says, "Oh, hey, I know something looking for an end. That module. This makes a pair." At this point in time, the parser's not raised any syntax errors because it doesn't see a problem yet. It is totally cool with this code. All right, so finally it gets to our second end, but there's nothing to match with. And so a syntax error is raised. right now, this is the error you get from Ruby on this code. It's not helpful to a human because deleting that end won't solve everything. Another way to put this is that parse errors are inherently different from human errors. What caused the problem is not necessarily the problem that the parser sees. Dead end's goal is to turn that parser problem into something a human can see and instantly recognize as an issue. How does dead end work? Well, it uses a library called Ripper. No, it's not a band name. Ripper is Ruby's parser that ships with Ruby. You can just require it. How cool is that? There's no external dependencies for this gem. Ripper can evaluate code and tell us if there's a syntax error or not. We saw this code before. There's syntax error right there. If we give it to Ripper, it says true. Yeah, there is a syntax error. If we fix the error, we add a space, then Ripper tells us that it's fixed too, which is pretty neat. We can use Ripper to evaluate. If we could fix the source errors, then Ripper would tell us whether or not it was, we had made a valid fix or not. But that's hard to do. It's hard to say, oh yeah, let's add a space here. I bet that's what the developer wanted. Could we do something simpler? Well, if we go back to our code with the syntax error, instead of fixing it, if I find code I don't want around, I just comment it out, So let's just do that. Let's try that. Okay, well, no, it didn't work. Maybe we keep, okay. So Ripper says that's good. No errors here. We've commented out the source code, finding the problem. And so now we see where the issue occurred. It's, pretty neat. If you remember our stranger and the mess that they left behind, well, Ruby knows that there's a syntax error here, but it doesn't know where. So it will tell you that the problem is on the last line. Again, not helpful. What does dead end do? Dead end uses indentation and some lexical parsing to deconstruct the source code from the outside in. Commenting out the code removes that node. Commenting out this other line removes this node, and still invalid though, so we have to keep on commenting. Okay, finally, at this point in time, all of the orphan syntax nodes are gone. Our tree is valid. And here's the actual dead end output from that code. It's pretty neat. It shows you that the else and the end are there, but it as a developer, I'm like, shouldn't there be an if? I'm pretty sure I put an if there, but dang that Octothorpe. I bet you're thinking, wow, okay, that was easy. So all he did was comment code based on indentation. Well, there are some gotchas. Let's look into them. Number one, we know the developer has a syntax error, so they've already done one thing wrong. We can't assume they've done everything else perfectly. We can't assume perfect indentation. For example, in this case, we have a syntax error right here on this line. It's missing a do. Without it, the parser has an extra end right here, right below it. So if we only look at indentation, then we would start removing this line, and then we would remove this incorrectly indented end. And then with that end gone, the document parses. Why is that? Well, it's because this keyword, that do up there, now matches with that end down there. It's not what we wanted, and we didn't capture the source of the syntax error. How can we fix it? Instead of only looking at indentation, we can also use something called lex output and lexing. Ruby ships with a lexer as part of Ripper. Here's what that looks like. Inside of this lex output, it will tell you that our code contains a do, as well as it also contains an end. So we can use this information to help find the problem. We're going to start in the same place, remove the same line. Now, when we go to the end, dead end says, oh, I don't want to remove that right away. That might trigger a false positive. So instead, it searches up, and what does it do? It finds a keyword, and it says, oh, sweet, we found a match. So it can remove both of them, and it doesn't have to, it says, all right, that shouldn't introduce a false positive to this case. With that safely removed, it can continue on with this process, and this is, again, the actual output of dead end. So it found our case missing the do. Even with correct indentation, removing the wrong line can show false positives. Here, our syntax error is on those lines right there. It's missing a method definition, like def hello or something. If we tried our indentation comment out strategy with the largest indentation, we would start right here. Cool, seems good. Let's remove it and see what happens. Well, now, what? Wait a second, the document is parsable? It's not even close, right? That's not even close to our syntax error. Well, what's going on? What is Ruby thinking? This is what Ruby's thinking. It says, okay, this class, all right, cool, that's a keyword. It matches with this end, so great, I've got a pair. We can keep on going. And then it thinks that this end is actually a method because of this trailing dot at the end of that line. Do not create a method named end. It won't end well. Laugh track. Finally, it thinks that this method definition matches with this last end, and that's a problem because none of this is our intended use case, and this is not helpful. But wait, there's more. Here docs cause problems. If you evaluate this last line in isolation, it looks like a constant. But if you remove it, we just introduced a syntax error. Yeah, not good. And there's more. When will it stop? These trailing slashes can cause problems. So here we go. We start in the middle. We go out. We see an end. We see a matching do. Look, should be fine to remove, right? Should be good to go. But this is not valid Ruby code. So I know I'm sad of hearing that trombone effect thing. Okay, so what should we do? We can use the lexer to detect these specific edge cases. And we can use that information to combine logically consecutive lines together, so there's no way to remove one without removing all of them. It's hard to show visually, but essentially it looks kind of like rewriting source code. The trailing slash would become something that looks kind of like this, in theory. Our method chain would become something that looks like this. And our here docs that are causing problems would, end up something like that. So with all the problem lines joined together, they can now be safely evaluated and removed without having to worry about either A, accidentally introducing a new syntax error, or giving us a false positive and saying we found the problem when there wasn't one. So, yay! Okay, gotcha number 3. Even with joining lines, even with lexically aware scope search, even with a perfect algorithm, there's one problem we can't avoid, which is ambiguity. Yes, ambiguity is the Comic Sans of source code parsing. Okay, what do I mean by ambiguity? It's kind of an ambiguous phrase, isn't it? This code has a syntax error. It's ambiguous based on how we are doing that expand on indentation and keyword. So let's zoom in. Starting from the middle, if we use lexical expansion, we get this match. When it's removed, there's still a syntax error. We need an end that matches this, but we don't know. We're going to highlight that. We're going to remove it. And hey, all right, it parses, great. But that's not what we wanted at all, right? This clearly is not our problem. To produce good results with invalid indentation, it means that we have to more or less kind of make some bad suggestions sometimes. And there's a logical inverse of this problem as well. So this code also has a syntax error, but this time up at the top, this time missing a keyword. If we focus this time, gonna simplify it a little bit. Does it look familiar? Here we go. Before we were missing the end, so we're missing the end right here, and in this case, over there we are missing the keyword. So it's the exact same problem, but just flipped on its head. When we run dead end, both of them just try to tell us that this is where the problem is, which not helpful. Right. So if we rewrite the rules to let indentation take precedence over lexical keywords, then it would make other examples fail. We can't do that. It's impossible to satisfy all the search criteria. How can we change this so that we can make this impossible choice? Well, what if we just didn't? Because we know the ambiguity exists, we can compensate for it after the search is done. Even though this is all the user might see on their screen, dead end still has all the contents of this block that are hidden. It just didn't match a single line, it matched many lines. If we unhide the rest of them, this is what it would look like. We can detect these specific cases, these ambiguous cases, and expand them to grab that end and then work backwards and then find the unmatched keyword. And then we present all of this extra context back to the user and they can resolve the problem visually. So syntax errors also aren't always alone. And that brings us up to gotcha number 4. A document can contain multiple syntax errors. There's multiple problems here. Starts with an end, didn't start off on the right foot. Missing a square bracket. I don't even know what's going on here. Lots of stuff wrong. So this code's fine. Cool. That code's fine. Also cool. What we don't want to happen is there's a syntax error on the bottom and on the top. What we don't want to happen is to start on one side and then just evaluate all the code and be like, oh, yep, hey, here's your entire document back to you. Sure, yes, the syntax error exists in the entire document, but it's not helpful to also show the valid code. So what can we do about it? We can modify the algorithm to find and hold multiple errors. Instead of searching from one side to the other, we search, outside in, which we get, kind of already saw that a little bit, but it finds a problem number one, finds a problem number two. Oh, gets here, says, well, that looks valid. We're going to just, looks good. We're going to hide it. We don't need to show it to the user, and finds syntax error number 3. So those are our main gotchas. We can now move on to the exciting part. Now move on to artificial intelligence. Who knows what AI is? Anybody? Raise your hand. Raise your hand. Type me in the chat. So artificial intelligence is a really fancy way of saying algorithm.
I am more than an algorithm.
Oh, come on. No, you're not.
Fine.
See, even the robots agree. A common example of AI is pathfinding. You want to get from point A to point B. Dead End uses a search algorithm to find our problem code, which is a variation on uniform cost search. Uniform cost search is also sometimes called Dijkstra's algorithm because he invented uniform cost search. I highly recommend this interactive page, Reblob's Game, as an introduction to search. I just find it really fascinating. In general, search algorithms are really good for when you know what your goal is and you know how you can manipulate the world around you, but you're not sure quite how to get there. Before, we saw that code can be represented as an abstract syntax tree. And that was kind of an important realization to me, as most search problems are represented as a tree or a graph. For example, here's a famous early chess problem being represented, back in 1984, talking about artificial intelligence, more or less. If you have an exact tree, you can walk the tree. In our case, we have bits of source code, and I found that if you give it rules about how to create logical blocks, then you can also use Ripper to check the document without their presence, and that will effectively complete our search. So now we know a little bit about AI. Let's take a look at some of the internals in the algorithms. If Dead End was a cake, here's how we'd start making it. Here's your messy code with a syntax error, and we're gonna have to first clean it up, tidy it. We're gonna give it to our search algorithm, which is terrifyingly hilarious, represented by that picture. And once the syntax errors are found, the output is decorated with more context and given back to the user. Let's start at the beginning. So your app has a syntax error. It's never happened to me before. It happens to me a lot. So like all good libraries, Dead End uses monkey patching. It's funny because it's true. It's not true. Not all of them use it. It hooks into require and friends, and then when a syntax error is raised, it is passed to Dead End. The source code that caused the syntax error is read into disk and passed into a search object. So we don't want to just use the raw source code. First, we're going to have to clean it up. We first pass it to our clean document class, and it handles several of our gotchas that we talked about before by transforming the source code. It's going to clear out comments and stray white space. It's going to join lines with trailing slashes. It's going to join lines with chain methods, and then finally handle our here docs. And then internally, it represents all of these lines as a object type called a code line. Yeah, I know, pretty inventive. But those code lines and the array that holds them, representing the document, is then passed to our search class. The fingers again, the hands, looks handy. Here's our code search class. And here is call. Like all good artificial intelligence algorithms, it's powered by a while loop, and we have a class called the frontier, which holds all the code blocks we've generated so far from the source code. The frontier is responsible for checking the exit condition. So either we found all of the problems or not, or we have to keep looking. If the highlighted code lines are on the frontier, then the entire document without the lines are checked against the parser. So that's what we kind of saw before. And here's where the parser is called, if you remember Ripper from before. So let's walk through the logic of searching the same document we saw before from the beginning. We don't hold all the errors, so we're going to continue. There's two modes of exploration. Which should we do? Well, let's check out the definition of that expand method. We can't expand something if it's not there, so it's already false. When that's not the case, though, we use indentation to decide when we're going to expand. There's nothing to expand yet, so this is going to be false. And we have to add lines to our frontier first. The code here is looking for the largest indentation and iterating up. We saw this before. This step only uses indentation if the block is found, and it's valid Ruby code, it's essentially commented out. And we saw this before. Boop. The code is then pushed back onto the frontier and the loop continues. We've still not found the problem, so we have to continue. There's still lines with more indentations, so we're not going to expand yet. We're going to need to add those extra lines. We found this line and add it. All right, so that's all of the lines at that indentation level. It is actually time to now expand our frontier. The final frontier would have been a good Star Trek joke place. Pretend I added one in. Tell your friends I did. Here's our expand code. The frontier is stored in indentation order, so the highest indentation is popped off. That's the furthest out. The block is expanded using an object and pushed back onto the frontier. How does that expansion work, though? Well, we can either expand within the same indentation, aka neighbors, or we can expand back one indentation, so not as far out, less indentation. Both of those methods use a class called the around block scan, which acts as a DSL for scanning up and down. And this is where we give our algorithm rules about how to build blocks using indentation and lexical data. Previously, we captured this line right here and put it on the frontier. When it's popped and expanded, it looks around and finds a match set of keywords. It finds that if and that end using our scanner. The new code that it found is valid, and so that's hidden. And that expanded code, even though it's hidden, is put back onto the frontier. That's pretty much how the algorithm works. It keeps looping, expanding, adding, until all of the syntax errors are found. Once we've removed all the syntax errors, then we still have to find our problematic code. Remember, there can be multiple errors, and the frontier can hold more than one syntax error. We want to iterate over all of the invalid blocks stored on the frontier and create a combination of all of those possibilities. We then loop through them and check all of the various combinations and return the smallest successful one that satisfies our criteria of making the document parsable. So here's where our search started, and then we found the invalid blocks, and then now we want to decorate our output. We pass it to this pretty printer display, the display invalid blocks class. Internally, here is where we take care of the last of our gotchas. So this class, this capture code context, handles the ambiguities we talked about before. It knows the various ambiguous cases that we have. We looked at this case and it's not a good match. So instead, what it does, it finds the end, it loops back, it finds the kind of orphan keyword, and it says, oh, you actually probably meant this, and it transforms it. So piece of cake. Put it all together, and you've got a gem called dead end. After all three steps, cleaning, searching, and formatting, here is our output. I'm pretty pleased with it. And that is dead end in a nutshell. Thank you. Thank you. I'll be here all week, folks. Woo. All right, beyond dead end, there's an amazing gem I want to tell you about, which is called error highlight. I'd like to highlight it to you. It's actually being included in Ruby 3.1, and it shows you which method got a no method error on it. And I freaking love this. I love this as an introduction. The error highlight gem was created by Yusuke, who goes by Mame on GitHub, and gave an amazing talk at a conference I used to run called Keep Ruby Weird. I recommend checking it out. Yusuke does some awesome stuff with Quines and made one especially for the conference as well. So that was pretty sweet. With error highlight and dead end, I also want to touch a little bit on community values. I've been writing a little bit of Rust code. couple of months, not much. But I've noticed that their community takes a really aggressive stance towards error messages. Here's, some example output. And it's not just enough that they say, oh, here's a problem. They also want to accurately suggest how to fix the problem as well. So with only a couple of months of Rust under my belt, I found some output that I was like, hey, this was a little confusing. And I opened up an issue, and within a month, people tackled it and, fixed it and merged it. And I mean, I'm not saying it's perfect, but I'm not saying it's a perfect community, but I love that this community treats user experience problems as a bug, and they treat error output as first class features. So just saying, if our community wanted, we could invest more in errors. Error highlight, dead end, these are good things, but they're not necessarily the end solution. It's just a start. Also, if you're wondering, hey, what can I do? Well, you can add dead end to your project right now and try it out today. You can give me feedback on what works and what doesn't. Hopefully we get that sorted out before Ruby 3.2 ships. You can also, if you're interested in contributing to Dead End or any project, you can pre-order my book on how to open source.dev. You can also sign up to triage issues on Code Triage. And so today, recap, we talked about lexing, parsing, syntax errors, AI, pathfind. Oh, it's written right there, pathfinding and goal seeking. But the technical pieces are not, I don't know, they're fun. I like slides with a lot of code on them. But are you going to remember that line of code that flew by like 20, 100 slides ago or something? Probably not. Those technical pieces aren't really the important part here. What I want you to remember is that the important part is that everyone sitting in this room is the future of developer tooling. Programming is inherently difficult, but it doesn't mean our tools can't help us. One of the best ways to judge a system, in my experience, is to see how it fails. When we can give care and grace and beauty to our failure modes, then we can create experiences that delight us. Experiences that teach us. Experiences that elevate our code and our consciousness. A syntax error doesn't have to be an ending. It can be a beginning to a beautiful programming story. My name is Richard Schneeman. You may have heard I'm writing a book on how to open source. You also may have heard I run Code Triage.
I want you to go forth and be an exceptional programmer. Bye-bye.
Bye-bye. Thank you. Zoom wave, everybody. Zoom wave. Oh no, they found me again. Oh. You're still here? It's over. Go home. Go